The command module would be traveling at 25,000 miles per hour when it hit the upper atmosphere.
If you travel down the highway, you're traveling at 60 miles per hour, you're traveling at 88 feet per second. We're coming in at 36,000 feet per second.
It smashes into the atmosphere. It doesn't fly as much as smash.
To protect the capsule, the engineers had built the largest heat shield ever. It was designed to disintegrate as the heated atmosphere tore into it. But to safely return the crew, the command module would have to re-enter at exactly the right angle.
If you came in too shallow, coming in and not gathering enough drag from that from the shallowness of the atmosphere to slow you down, so you'd keep going right through the atmosphere and out the other side. If one came in too steep, this was more like a belly flop off a high diving board into a pool, because the atmosphere, for all its fragility when we're walking through it, when you're coming in at Mach 30 or so, it's very dense. And if you hit it too deeply, you could break up the command module itself. So everybody was highly motivated to sort of stay in that boundary.
The command module needed to maneuver in the upper atmosphere, but it was not easy to steer a blunt capsule traveling so fast.
The way we steer the command module is little reaction jets here that roll this vehicle. The only thing, it can't turn this way, can't turn this way. All it can do is roll a little bit about this axis. It's a very rudimentary control mechanism, but it worked.
A returning Apollo capsule would deploy its first drogue parachutes while still 25,000 feet up and traveling at 320 miles an hour. Then at 10,000 feet and still traveling at over 160 miles an hour, the main chutes would be opened. For a safe landing, these giant canopies would need to survive unprecedented speeds without shredding, to slow down the spacecraft to less than 20 miles an hour.
No program before or since has ever had a parachute that was so thoroughly tested.
With the designs perfected, it was time to manufacture them.
There's approximately a half acre of very lightweight nylon fabric. We call it ripstop. In each main parachute, there's approximately 2 million stitches. The suspension lines are 1.5 miles long. It takes about a week to pack this very, very, very tightly under hydraulic presses. And when we finished, the density of the fabric was like maple wood. These ladies took great pride in what they did. They all seemed to understand more than many of us that their sewing was the last important step in returning these astronauts safely home.